Alright, so let's look at a third one. Now, this is the first one where all of my denominators are not already factored. So you notice x minus 4, that one's fully factored, and so is x plus 2. But the x squared minus 2x minus 8, that is a trinomial with an a of 1. So I need to know what that is in its factored form. So we know we need x and x. My c is going to be negative 8, and we want that to add to negative 2. So I believe our factors are going to be minus 4 and plus 2. So once everything is fully factored, we're going to determine the domain. And remember, we said for the domain, we set each unique factor in the denominator equal to 0. So I have an x minus 4. I'm going to set that equal to 0. We have another x minus 4. It's not unique. And then I have an x plus 2 to set equal to 0. And then there's another one of those, but it's not unique. So if we solve, we get x equals 4, x equals negative 2. So for the domain, remember those are my bad values. So x cannot be negative 2 or 4. For the LCD, we talked about these also in the previous lesson. We need one of each unique factor. So we're going to need an x minus 4 and an x plus 2. So then we have to multiply every term in the equation by that LCD. So we're just going to write it basically in front of each one. And I'm going to leave this in its factored form. Makes it easier to see what cancels out. Alright. So for our first term, we have an x minus 4 and an x minus 4 that match. So we can cancel those out. That's going to leave me with x times x plus 2. In the second term, I have an x minus 4 that matches, as well as an x plus 2 that matches. So the only thing that's left is the 18. And then for the last term, I have an x plus 2 that matches. So I'm left with a 3 times the x minus 4. So if we clean this up, I'm going to distribute x times x is x squared, x times 2 is 2x, minus the 18 equals 3 times x is 3x, 3 times negative 4 is negative 12. I see that my highest power of x is a squared, so this is quadratic. So once again, we're going to need to get equal to 0, factor, and use the 0 factor property. So both the left and right hand side at the moment are as simple as they can get, so we can start moving things over. So I'm going to subtract 3x. That gives me x squared minus x minus 18 is negative 12. And then we are trying to get equal to 0. So I'm going to add 12 to both sides. So I get x squared minus x minus 6 equals to 0. So once we're equal to 0, now we can factor. So I know that I want factors that multiply to -6 and add to -1. So we're going to need x minus 3, x plus 2. Zero factor property says I set each one of those factors equal to 0 and then solve. So my potential solutions, we have 2 this time. X equals 3, x equals -2. So first I'm going to check them against the domain. The domain said x cannot be -2 or 4. So that means this one is out because it is not in the domain. So now my only potential solution is x equals to 3, and I need to check it in the original equation. Alright, so this is a little bit tedious as well. Everywhere there is an x in the original equation, we're going to substitute a 3. So we'll get 3 squared minus 2 times 3 minus 8. And we want to know if that's equal to 3 over 3 plus 2. Now we're going to make use of our calculator here. I'm going to go ahead and simplify this one. 3 over 3 minus 4 is -1. I picked up my calculator and I put in 3 squared minus 2 times 3 minus 8, entered that straight in, and I got -5. And then on the right hand side, this is 3 over 5. And then I used my calculator again to enter the left hand side. You need to make sure that you don't just watch me do this. You need to practice with your calculator and make certain that you can do it, because you're going to need to show this check on your homework and on the test. So make sure that you can use your calculator to get these, okay? So if I enter 3 over -1 minus 18 over -5, that should come out to be 3/5. If you don't get 3/5, you're probably not entering the signs in correctly. If you continue to have trouble with that, please contact me and let me know. I'll try to help you get that straightened out. But this says that the solution x equals 3 does satisfy the original equation. So my solution is either x equals 3, or you can write it in set notation. Alright, the next one. These all really work the same. It's just slightly different things in how the denominators need to factor and how they come out. So for this one, the x plus 5, the x minus 5 are already in lowest terms, but we know x squared minus 25 is a difference of squares, which factors into x minus 5, x plus 5. So to find the domain, I'm going to set each unique denominator equal to 0. We have 2 unique denominators, x plus 5 and x minus 5. So if I solve, I get x is -5 or x is 5. Those are my bad values. X cannot be -5 or 5. And my LCD is going to be one of each unique denominator, which in this case is just x minus 5 times x plus 5. So now we have to multiply our LCD times every term in our equation. Yes, I realize this is tedious, but we do need to show all of these steps. Then we can go through and cancel any matches we have in the numerator and denominator. So we can cancel the x plus 5, leaving me with 4 times x minus 5. We can cancel the x minus 5, leaving me with 5 times x plus 5. And in the last term, we're actually going to be able to cancel both, leaving me with negative 4x. So if we clean it up by distributing, we have 4x minus 20. Don't forget we're distributing a negative 5. Negative 5x minus 25 equals negative 4x. This time the highest power on my variable is 1, so this one is linear. So I'm just going to collect like terms on the left. I have 4x minus 5x, that's negative x. Minus 20 minus 25 is minus 45, equals negative 4x. Now I told you I usually like to move my variable to the left, and I do, unless the easier or lazier way is to move it right, and in this case it is. So I'm going to add x to both sides. That leaves me with negative 45 equals negative 3x. Then if we divide, I get x equal to 15. So I only have one potential solution of x equal 15. If I check it against the domain, that said x can't be negative 5 or 5. So we're okay there. So then I would need to check it in the original equation. So everywhere I have an x, I'll need to substitute 15. So we get 4 over 15 plus 5 minus 5 over 15 minus 5 equals negative 4 over, negative 4 times 15 over 15 squared minus 25. Now I'm going to leave us here because I want you to practice using your calculator. X equals 15 is a solution, so you should be able to get the two sides of that equation equal to each other. So I want you to practice that and make certain that you can. All right? We're going to look at one more. All right, for this one, the first two denominators are in lowest terms. The third one, we have a GCF of x. So for the domain, I'm going to set each unique denominator equal to 0. So x is equal to 0 is finished. This one gives me x equals -2. So I know for my domain, x cannot be -2 or 0. My LCD is going to be x times x plus 2. And we're going to multiply that times every term in our equation. Alright, then we can go through and cancel. The x's are the same. That leaves me with 5 times x plus 2. The x plus 2's are the same. That leaves me with x times x. And then both of those cancel, leaving me with a 4. So we get 5x plus 10 plus x squared equals 4. My highest power is a squared, so quadratic means I need to be equal to 0. I'm also going to put this in descending order. X squared plus 5x plus 10 equals 4. We have to be equal to 0, so I'm going to subtract 4. I get x squared plus 5x plus 6 equals 0. Now we're ready to factor. So we want factors multiply to 6 and add to 5. So this time we need plus 3 plus 2. Zero factor property says we set each factor equal to 0. So we get x equals -3. And we get x equals -2. So these are again my potential solutions. Are x equal to -3, x equals -2. My domain says that x cannot be -2 or 0, so that means this one is out. So that leaves me with one potential solution to check in the original. So we get 5 over -3 plus -3 over -3 plus 2. We want to know if that's equal to 4 over -3 squared plus 2 times -3. So I'm going to leave the 5 over -3. If I clean this one up, that's -3 over -1. And then on this side, I entered into the calculator the -3 squared plus 2 times -3, and that gave me a 3. And then the next thing I did is pick up the calculator again and enter 5 over -3 plus -3 over -1. And that did give me 4/3 is equal to the 4/3. So that means my solution is x equals -3, or of course you can write it in set notation.